was dramatic. So welcome back. I think we can slowly get started, and as always, we'll get started with a brief review here. So what we did last week was look at lots of different ways of evaluating appeals to authority, of evaluating sources, and we saw that that can, on the one hand, be a really central part of really any kind or of many kinds of argument, and that is a kind of argument that in practice we have to rely on all the time. But they're also kind of tricky because the same kind of argument can either lead you to accept a conclusion, so provide good reasons for accepting a conclusion, but it can also lapse into informal fallacies. So it's kind of important to keep in mind both sides, that there are kind of two sides to this coin, really central, but can also be misused, abused, and go wrong. This is also something that's going to be central to the third assignment task, which has been online since yesterday. So if you want to have a look, the examples there are basically going to be two different web pages that are loosely related around the same claim. So you'll have to do a bit of extra research to evaluate those. It does tell you in quite a lot of detail what individual questions you have to answer. So you'll have to do a bit of research. You also have to kind of come to an overall conclusion on the claim being discussed there, where I just want to see that you've done a little bit of independent reflection of your own independent argumentation. But for the evaluation part, the main three things, both in general and for the assignment task, are going to be these three questions. So given that an appeal to authority rests strongly on a claim that an individual person is actually equipped or an expert or was in a position to have reliable information on a given claim, we'll have to evaluate whether that premise is actually true, whether that's actually trustworthy, and then you can always ask these three different kinds of questions. Additionally, in a longer text, you'll also have to figure out what the claim being argued for actually is, but the assignment task will tell you that. While on assignment tasks, I'm into AT2, not quite done with it, but I hope to have it to you within the next couple of days, so I'm doing my best. So to continue with review, and if you have questions on that, we can always discuss them in the tutorials as well. I was saying that there are always kind of two sides to the coin of appeals to authority. And really common ways in which they can lapse into informal fallacies are just these four. Here there are other ones, but these are the main ones that we had discussed, so that's kind of a good thing to keep in mind. First way it can go wrong, it's just a bad appeal to authority. The person wasn't in a position to know. The person is an expert on one thing, but whatever they're an expert on isn't what they're claiming. So it doesn't have the relevant type of expertise, and so on and so forth. Personal attacks, very popular, easy way to discredit an opponent and a claim, but also a very bad way, right? You can't really disprove a claim by showing that the person somehow has bad character or by doing some kind of character assassination. That's not good form, and it's also an invalid argument. Guilt by association is a version of that, also an easy, intuitive thing to do, but again, not a good thing to do. And arguments from ignorance, which also tend to be quite popular in questions of belief, widely understood. And that's just the final reminder. Appeals to authority can be good, but the conclusion can still be wrong, right? So it's not guaranteed to be true, even if the appeal to authority is very strong. Historical examples of that exist, and you can think of more than the one on this slide. It's important to keep in mind that undermining an appeal to authority does not show the conclusion to be false. It just shows that you don't have, given the appeal to authority, good reasons to accept it. But you can't, again, disprove a conclusion by undermining an appeal to authority, because that's just a personal attack, right? So it's kind of important to keep in mind that it's not completely symmetrical in that way. That clear? Good. Because then we'll move on to our next Next topic, which is our actual topic for today, so evaluating generalizations. We'll be looking at different kinds of generalizations. So first of all, at universal ones, all, A, R, B, and so on and so forth. We'll be looking at two strategies for evaluating them to do with counterexamples, which is something you're already a bit familiar with from looking at valid and invalid arguments. And we'll also be looking at inference to the best explanation. And then we'll be looking a little bit at statistical generalizations as well. And there will be a little bit of a math example, but don't be terrified by it. It's very easy. And just kind of an informative thing to do. So generalizations, where are they important? Well, again, this is something that we're going to be encountering everywhere. They're especially frequent, or maybe especially important or relevant in some sense if you're looking into religion and ethics, and we'll actually be looking at some of those examples in the tutorial. So claims about laws, about general obligations to do something or another. Claims about what type of action is generally morally good or morally wrong would standardly take the form of generalizations. But the other group of them is going to be something like this, so statistical generalizations, where you're not really talking about all members of a certain group, but just about a certain percentage. And at this point, I just ask you to read this. Or actually, I'll just read it out and think about what the answer to that would be. So we take the example of a fatal disease spreading, and it doesn't affect very many people, just 1 in 10,000. But you undergo a test. The test is 90% accurate. Which means that 90% of the people who have the disease get a positive result, and also 99% of the people who do not have the disease get a negative result. That's just what 99% accuracy here means. You get a positive result, you're devastated, and the question is, how worried should you really be? Maybe just intuitive show of hands, just gut feeling. It's very likely that you have the disease. You should be very worried. How many people think that? Mm-hmm. How many people think, relatively likely, at least more than 50, but not really going for a strong reaction? Mm-hmm. What about C? Still fairly likely, but under 50. How many people wouldn't be worried by this at all, or almost at all? Remember what you thought here. Even if you didn't raise your hand, remember what you thought. We'll be coming back to this later. But at least most of the people who did raise their hands seem to think so that was the biggest group. Somewhat concerned, somewhat likely. So just remember that one. We'll come back to it. So general statement of generalizations. Claims about all things of a certain kind, all members of a given group, all kinds of situations or cases, and they're claims. So if you remember the definition of a claim is something that can be true or false, and obviously evaluating them will depend on exactly that. Another point why I put this there is that you can't criticize a generalization just because it's a generalization, right? Not all generalizations are just per se bad. So actually something more is needed here. So obviously true ones, again, these are lots of familiar ones, right? Some of them will just be true by definition. That's just what the concept for instance, means, or maybe there's just a law, for instance, describing entry requirements. That just obviously makes the generalization true. Maybe it's really easy to see that it's true, all cards on the table, and so on and so forth. So those are going to be the uncontroversial and fairly uninteresting ones. And then there are going to be others that are just obviously false, and some, and that's of course where it gets more interesting, that are kind of murky or unknown. And of course much of the actual work is going to be located in that area. So exactly these types of either predictions maybe into the future or something like that, or ethical claims of some sort or another. And again, this is familiar, but we're going to be looking at it in more detail. Again, you can use these kinds of diagrams to map the relationship of such universal generalizations and to kind of just depict what exactly is being said. So in this case, this is pretty much a no-brainer, right? None of you would be confused about this at this point. All leopards are carnivores. So there's a domain, animals, that this belongs into, and this is obviously the smaller group of that. So that's not rocket science. It does get a bit more interesting later, as we'll see in the tutorials, because sometimes in some forms of statements you obviously don't always get that in a text, right? All A or B. So figuring out what exactly is being said can be a bit trickier, and that's where this gets interesting. Sometimes the domain isn't explicit, right? In this kind of a statement, if a person is under 18, they're not eligible to vote. That probably isn't a claim about all people in the whole world, all people that have ever existed in past, present, and future times, all people in the universe, whatever, right? It's probably a more restricted claim, so there is, so that's kind of important to think about that. It's also a covert generalization in another sense, because it does look like an if-then, a hypothetical statement, but it is still saying about all members, something about all members of a certain group. And the general form is again just going to be something like this. If something in general is an A, then it's also a B. All A are B, and that's again the familiar thing that you already know. So that was the squashed, simple version. So what goes in what circle here? Does anybody immediately have the answer for that one? So is only celebrities are invited to my party, which what's A and what's B in this one? Someone talk to me. So the small circle is obviously the people who are invited to the party are a subgroup of all celebrities. It isn't the case, and thanks, it's not the case that every single celebrity is invited. It's just that subgroup of people. But everybody, you can also see everybody who is coming is in the larger group of celebrities. So that's just what that's saying, right? And we can reword this sort of like that to get that into a more, into a statement that sounds more like a universal generalization, into that standard form. So everyone who is invited, or all people who are invited to the party, are people who are celebrities, which is a bit clunky, but that's the kind of strategy we'll be using for the more complex cases. And then obviously you can have cases like this where there are two separate groups that share no members, right? So that would be one way of depicting this. All instances of A are not instances of B, in this case of justified actions or something like that. And you can also twist that around by saying something like this, which is, in language, would have the same paraphrase as that, what I just said, but you're just changing the groups. Now you're not having one group of justified actions and one group of killing humans, but you're saying that that is a subgroup of unjustified or not justified actions. So those would just be two different ways of kind of depicting that and maybe visualizing that relationship for yourself. And that also means, if we break that down into general terms, again, that these two things are equivalent, right? So no A is B is going to be the same thing or equivalent to all A are not B. Yeah? So that's kind of a thing to remember, and again, we'll be using that later on in the tutorials. Okay, maybe then we'll look at a more interesting example. Are there questions at this point? Okay. So it is a principle of economics that a nation can experience economic growth only when consumer confidence is balanced with a small amount of consumer skepticism. And the question is going to be, which of those two examples, A or B, is an application of that general principle? Yeah? So option 1, any nation in which consumer confidence is balanced with a small amount of consumer skepticism will experience economic growth. And option 2, any nation in which the prevailing attitude of consumers is exclusively confidence will not experience economic growth. And the question is, which one of those is an instance or an application of that general principle? Yeah? How many people say A? I'm always uncertain at this point. Is it nobody wants A or just nobody is saying anything? How many people say B? Okay, good. Can somebody explain B in one sentence? Or do I have to do all the work? Excellent explanation, and we're done. That's exactly the application of critical thinking that I want to see on all assignments, right? No argument, just that one's wrong. Perfect. Perfect instance. Of course, at the end of the unit, you'll all be authorities, so you'll all be able to do this. Okay, so I'll do the explanation for now. So here's our right answer. So task 1. And sorry about my sense of humor. That's just what it is. Thanks for answering that. So first question is going to be how to depict the general principle, right? So what is being said? What is a subgroup of what? And in this general principle, we can see that economic growth happens only when those two conditions are fulfilled. So confidence balanced with skepticism is the only way that economic growth can happen. That does not mean that always when we have those two conditions, economic growth will happen. This is just a subgroup of that. So that's the first important thing to see. All instances in which economic growth happen are instances in which confidence is balanced with skepticism, not the other way around. And then if we look at those two examples, then we can already see that B, so the correct answer, is just plain outside of the circle, right? In that case, in B, we have a nation that has all confidence, no skepticism, so it can't form part of the smaller circle. That should be clear. And if we look at the other example, at the other option, that's a bit different. Any nation that has that balance will experience economic growth. Well, it might, but it also might not. So there are counterexamples to that claim, so that doesn't match the principle. Clear? Tess? Only when consumer confidence.
So is that not a biconditional then?
That's not the if and only if.
Okay, so only if is different to if and only.
Yeah. So that's different. If it were if and only if, then it would mean that both sides, so basically we would have two circles of the same size, right? So then we could also reverse it. So then all of these would be instances of these, all of these would also be instances of these, but that's not what we have here. That's the only one, yeah? And that's where it gets tricky. So usually the only when will be the more typical one that we have in normal text, and that's kind of one to pay attention to. Yeah. Any other? Okay, so that's the quick summary that you can go back to if you want. So just what types of things will these different types of diagrams allow you to say and not to say? Blue versus red, so you can look at that later, and that is kind of the end of the universal generalizations point. So then we move on to how to evaluate them and to the two strategies of evaluating them. And strategy one you already know, but it's going to come in a slightly different guise. So it's going to be the strategy of finding counterexamples. And obviously, if we take a generalization, a universal one that says something about all members of a given group, right? If we take that as a claim, a factual claim, for instance, a general claim in the strongest sense, then it doesn't allow for any exceptions. So obviously, if you can find an exception, for instance, in this case, all swans are white, well, actually, no, there are actually some that are black, and if you live in this part of the world, you might, I think I've seen them actually around here, which was very, very cool from my weird European perspective. Then there are counterexamples to that rule, so the generalization must be false, right? So that's not particularly interesting. But it kind of fits in nicely with what we were saying earlier, right? So if you remember what we were saying about the strategies for finding out whether an argument is valid or invalid, we had said exactly the same thing. Say you have a form, a general form, and you don't know whether it is valid or invalid. Then you try to find a counterexample where all true premises will lead to a false conclusion. In this case, both premises have to be actually true. Why? Because if this were a valid form, then it could never be the case that true premises lead to a false conclusion. If this form were valid, then all instances of this form would be such that true premises would lead to a true conclusion. So that's a general statement about validity, right? Validity is defined in that as a universal statement about what kinds of conclusions or what kind of form such arguments will have. They're always going to be truth-preserving. So if there's a single instance in which a form is not truth-preserving in that way, then it's an invalid form. So that's exactly why we can use that strategy to evaluate validity and invalidity as well. Yeah, that's just a specific application of finding counterexamples to general statements. Do they always show that we should reject the principle? So this was the easy version of strategy one. And as always, there's going to be a murky reading for strategy one as well, right? And the murky reading and the interesting reading, that's always what I'm going to say, right? Where it gets messy, that's where it gets more interesting and more difficult, are always going to be the ones where you start thinking about maybe even saving the general principle by introducing exceptions or qualifications. So this is one. We've already talked about this a lot, where we have obvious or at least plausible counterexamples, and then you might just try to save the principle by introducing exceptions or by kind of formulating it in a more precise way. When should you do this and when shouldn't you do this? Again, this is really going to depend. So I think at least for these kinds of general ethical claims, moral claims, you're almost always going to use this strategy to even ensure something like real-world applicability, right? Or empirical plausibility, or however you want to call it, right? So some tweaking is typically going to be needed, but obviously if you're going to introduce an endless list of exceptions, that's not going to be interesting anymore either, right? So it's kind of it's a judgment call, and you kind of have to balance in each individual case and context the pros and cons of keeping the principle but adjusting or giving it up. That clear? Okay, so that was strategy 1. That was the familiar one. Strategy 2 for evaluating generalizations is going to be a little bit different, because strategy 2 is going to look at the explanatory relationship between the evidence that has been observed and the generalization. And this is so have people heard of inference to the best explanation? So that's one of the most common types of argument that you're going to find in science, for instance, extremely central. And this is kind of a very squashed version of how that comes in. So this is actually a very useful thing. And I'm just, as always, going to be doing it with a toy example. And obviously more interesting ones exist. So generalizations. All swans are white. All cats meow. How do we get to them? We're saying something about all members in a given group, but it's actually an inference from a limited number of observed instances, right? Unless you're saying something like all the objects on this table, where it's very limited and you can actually make the observation, you're usually, and that's exactly why you get that in science as well, or in psychology, you're usually just looking at a limited group of instances and generalizing. So that's typically that form, but we still think we can make interesting general statements. And one way to go at this is to say that in this case, and this is kind of weird because it kind of flips what you're doing, right? To say, why should we believe that all A are B, that all cats meow? Well, we should believe it not. So normally we would say, all of the observed ones have been like this, therefore this is the case. We now kind of turn it around by saying, well, if this were the case, if the generalization were true, if it were the case that all A are B, if it were the case that all cats actually meow, that would be a wonderful explanation of why all of the ones that we have seen have done this, right? So you kind of turn it around. If the generalization were true, that would explain why all observed instances have been like that and not different. So that's an explanatory claim moving from the generalization to explaining the observation in the limited number of instances. So that's the first step of inference to the best explanation, and that can't be everything, because you could have totally outlandish explanations, right? We could all come up with totally weird things. So it's interesting and important here then to think about how good an explanation is it. So let's take another weird example. Florks, new species of mature birds. All of the ones that have been observed are white. Nobody knows what they isn't important. That's why we're talking about florks, because nobody knows what they actually are. All observed ones are florks are white. Therefore, all florks are actually white. Just gut feeling. Is that a good explanation, or is it kind of intuitive to think that other better explanations, or at least equally good explanations, might be available? Yeah.
When you look at it, are you given the information, like if you have the information that leads to a few mature birds, then well, obviously you've got to think, what what about baby birds? What about mature birds? But if you've just given the bit you have in blue, then you might think that you've looked at quite a lot of the range of ages.
So it would depend, and I think that's exactly right, that this is kind of underdefined, right? There is an option, so we would want to know more about premise one, all observed ones are white. So we would want to know kind of how many have been observed, have different ages been observed, have they been observed in different regions, and so on and so forth, maybe by researchers in all countries where they occur or whatever. So you can pump more and more into this, and obviously, as you rightly pointed out, that is going to depend in part on how good the conclusion, how good an explanation the conclusion actually is of the observation. If I've just observed a few of them, and they're all mature, and that's also what you pointed to rightly, there seem to be a number of at least candidate alternative explanations, right? Well, maybe it's just the ones that are here, maybe it's just the mature ones, maybe it's just really weird coincidence. They come in all colors, but it's just the ones that I've seen, and so on and so forth. So even without knowing anything about this weird creature, right, we can still say that doesn't seem to be a very good explanation. And that's not true, so that's why the weird example. There could be cases where we have the weird examples of florks. We still don't know anything about them, but we have a different claim. All observed ones have livers. Why? Because all of them actually have livers. And you can see that here the question about how good the explanation is going to tip in another direction. Why? Because we have a general principle. If some members of a species have livers, that's obviously, or we expect this to be true of all of them, right? We don't expect there to be an animal such that some florks have them and some don't. That would be really, really weird. So in that case, we can say that seems to be a general principle. That seems to be a good explanation. It would be great if people wouldn't text during the lecture. Yeah, if people didn't text, that would be great. Like if you're, that distracts me, and you. Okay, so inference to the best explanation. So what is the summary then? We say, well, first of all, it is an explanation of the observed facts. And the second question needs to be answered, namely, is it a good explanation, and is it a better explanation than any of the other available explanations? And if you can answer both those questions with yes, maybe not the best explanation ever, but at least good and at least better than other obvious currently available candidates, then that is a good reason, or then the conclusion is likely true, then the generalization is likely true, right? So this would be your additional premise. The conclusion is not just an explanation of one, but it's part of the best available explanation of one, and therefore it's likely true. So this is a really, really common argument, good thing to keep in mind. Yeah? Questions? So that's argument from explanatory goodness or something like that. So summary, evaluating generalizations. Strategy 1, find counterexamples to the general principle, in this case to the conclusion, right? All A or B. If there are cases like that, either adjust the general principle or give it up. Strategy 2, is it really the best available explanation or even a good one? Right? Not good one, so you don't want to start introducing weird kinds of aliens or whatever, right? Or any kinds of supernatural powers, but actually good explanations. How good does it fit existing knowledge, and so on and so forth. That would be the second premise. And then another issue, and that was kind of the one that came up with the white florks, might be, well, you know, have the observation conditions actually been good? Might there have been an error in the observation, and so on and so forth? So that would be another strategy that we haven't discussed, but kind of an obvious one. Yeah? So far good? So then we can move to statistical generalizations, and that's going to be the last part for today. And again, a universal generalization is just going to be a specific subgroup of statistical generalizations where we're talking about exactly 100%, about exactly all, and not just many or some members of a group. So this can be done in percentages. This can be done in terms like most, many, some, very few, and so on and so forth. It can be covert, like in something like this, people who do such and such tend to do such and such. Then it takes a bit of a matter of context and judgment call to figure out whether this is something being said of all or some. And there might be cases where you don't really know, right, where it might be murky. But this could go both. Go both ways. In terms of evaluation, though, there's a bit of a problem here because the strategy of pointing to counterexamples obviously won't work for most statistical generalizations, right? It will really just work for universals because if you're just talking about even 99%, that immediately allows there to be possible counterexamples, right? You cannot refute a statement like this, most Germans drink beer, by pointing to ones that don't. So that should be obvious. So how do you evaluate them? And again, there are going to be two strategies for doing this. So strategy one, if you look at this, this argument here. So 95% of primary school teachers are female. The guilty person is a primary school teacher, so the guilty person is probably female, right? If you look at that argument, good, bad, immediate thoughts? I think we're reaching that point in the semester where it's kind of... So we can again think of it in something that is really similar to the forms that we already have, right? So strategy one is just going to think, try to identify and try to compare it to the usual argument forms that we have. And in this case, you can see that this form is a valid form, right? Because it's actually very similar to the universal modus ponens. It's just not saying all, but it's saying so-and-so many percent X is in that subgroup of so-and-so many percent, therefore. So the conclusion in this case is probably true. It's a valid argument form. Yeah, so this is just reusing what you already have. And that's going to cut in the same direction for different cases. So if you change premise 2 to the guilty person is female, then, and again, this is no news to you anymore, you'll have a form that is similar to denying the consequent, right? Affirming the consequent, sorry. So that will be an invalid argument form. That doesn't work, right? So that's exactly what we've been doing the whole time. And that would be strategy one for evaluating this kind of a pattern. Yeah? Okay. So then we move to a bit more interesting examples. And this is similar to what we were discussing at the beginning. So test case for a disease. Test is again 99% accurate. We already know what this means. Now Simon has a positive result, is likely to have is likely to have the disease. So what is going on here? Mm-hmm. So pretty sure it's B and valid. So it's, does anybody else want to? Yeah. So that's what we just had, right? Actually, that's exactly the same thing as we just had. So that's good. So that's an affirming the consequent, just in a harder to immediately see form because it's in this text form. So it's not a valid argument. That would be the reconstruction, yeah.
It's not a valid argument when you say anything about how likely it is that someone's going to have a disease.
That is the next slide. You have these abilities. So that's exactly where it gets interesting, right? So it's not very probable, but obviously what we want to know is not just is it valid or invalid, is it probable or is it improbable in terms of more or less than 50%, but we want to know what to go from here. So good. That shows that the structure of the slides is good. So what do you do from here? And that's exactly the example that we had at the beginning. And if you remember most, I think at least the largest group of hands went up, said it's very likely in this case. And actually the correct answer is it's extremely unlikely in this case that you have the disease. And the question is, how do we get there, right? So how do you determine this? We already know it's invalid because it's the same thing as we saw earlier. But how do we figure out what is actually going on here? How many people think this is surprising at this point? Or are you just beyond surprise? I mean, it is a bit of an intuition pump, right? Kind of working with 99%, you're devastated, whatever. So how do you figure this out? So what we are told here in bold in the text. So the disease affects 1 in 10,000 people. That's what we're told. That's our base rate. And I'll come back to this in a second. We also know something about how the test behaves, right? If you have the disease, 99% people who have it get a positive result, 99% who don't have it get a negative result. That's what we do know. But we've also seen, because we've thought about our standard argument forms, that the reverse is not true. This does not mean that 99% of people who have a positive result have the disease. It just means that if you have the disease, you're very likely to get a positive result, not vice versa. So that's just everything that we've been doing so far with a bit of percentage added onto it, right? But that's what we want to know, right? We have one instance where there's a positive result, and we want to know if there's a positive result, does that mean that the person has the disease? So this is the question we want to ask, but this isn't the question that's answered in the text, right? So that's point one, to make that difference. Is that clear? Okay. So this is, this part of it is important. So then how do you do it? Well, in this case, you might want to actually do the calculation, and you can do it with kind of a tree diagram like this. So say we imagine a population of 1 million people. And we know what the base rate is, right? I think in 10,000 people have the disease, so out of 1 million, that would be 100. Not rocket science. Okay, so that's what you do, and you figure out from that, it's obvious how many people in this fictive population wouldn't have the disease. And now you apply what you know about the accuracy of the test to this fictive population, right? So 99% of the people with the disease are going to get a positive test result. That's just what the accuracy condition in the text tells us. And one person will get a false negative result. And you can apply the same thing to the other side of the tree by saying, well, but we also know that 99% of the people who don't have it get the negative result, which is correct, and 1% gets the positive result. And then you just fill in those numbers, which with these numbers, again, is fairly easy to do, right? So then you have something like this. All good at this point? Yeah. So then you've just applied what the text has told us to this kind of fictitious population. And this gives you the resources to answer the question that we actually wanted to have the answer to. So how many people with a positive test result have the disease? Well, we can see that this is these people here, these 99, but it's also this huge group over there, right? So we add it together, we get the complete number, the total number of people that have a positive result here is actually very large. And we also know, because it's already right there, that only a small percentage of those, actually under 1%, actually have the disease. So that is exactly what gets us to do that calculation. So in that case, given this population, given that base rate of 1 in 10,000, a very small percentage of people will actually, with a positive result, will actually have it. There's no big cause for concern. Yeah, so that would just be one way of actually figuring that out. All good? Yeah? And I know from experience that this is the type of example that is really obvious to some people, but where other people get this kind of, oh my goodness, there's numbers and math reaction. So if that's the case, just go through it very slowly. The good news is you will not have to do this on assignment tasks, right? There will be a question about generalizations in AT4 and in the final exam. So the beginning of what I've been saying here is going to be really relevant, but you won't have to actually do this part, but it's a useful thing to know. Here's where it gets interesting. No, that's not where it gets interesting. That's what we already know. It gets a bit more interesting when we vary the base rate, right? And are saying it's not 1 in 10,000, but 1 in 100. So how worried would we be in that case? And again, we can go through the very same type of calculation, but suddenly we just have different numbers. Suddenly we have 99 out of 100 and one negative result for the people who have it. For the people who don't have it, which is now a much smaller group, we have 99 with a positive result and many more with a negative result. So it's just, yeah. And then basically what you get, doing the very same thing, adding up the people with a positive result, is suddenly you get a likelihood of 50%, right? And that's just from changing the base rate. So just 1 in 100 versus 1 in 10,000. And if you translate that into that kind of a diagram, that's exactly what you get. Yeah? Clear? So that's one way of figuring that out. So just to sum that up, how do you evaluate statistical generalizations? If you're inclined to do so, you can exactly use the base rate to calculate the likelihood, and here are kind of the steps summarized. I'm not going to go through them now, but you can read it up if you want to. More generally, so if you don't need to do that, you try and figure out whether it corresponds to one of the forms that we already know, modus ponens, modus tollens, the invalid argument forms. And you can also ask a number of further questions that we haven't discussed here but that might be relevant, right? How was the statistic derived? Is the claim clear? So what does it mean to say all observed florks are white? So what, we might need more details there. Are there possible explanations? So those are just the kinds of questions that you can start asking them. With that, we're done. And see you in Toots.